Okay, so when we're solving equations, the goal is to get the variable to be by itself, because you want your answer to be x equals 7, or x equals whatever the answer is, right? So the variable has to be by itself. Whenever you're solving equations, you're going to use what we call inverse or opposite operations. Inverse is sort of the fancier word to use there. And you're going to work backwards. So we already really know this. Addition is the opposite of subtraction, right? And multiplication is the opposite of division. As we go along, you're going to learn some other opposites, some other inverse operations, but for right now, we're just going to be sticking with those four. Whatever you do to one side of the equation, you must do that same thing to the other side of the equation. Okay? This means that the two sides are still equal, right? And last thing, you always have to plug your answer back in to the original equation to check it, or you should. I do not usually make you do it every single time, but I will make you check occasionally. And especially quizzes and tests, you should be plugging your answers back in to check to see if they work. So we'll see what that looks like here. All right, so as we move forward, there's going to be some of you, maybe about half of you, that are like, oh, this is too easy, I can just do it in my head. So I need you to think about solving equations last year with Miss Ball. And were you good at it? So, like, I'm not talking about the ones we're going to do today, because the ones we're going to do today, we're going to start off with the most simple of equations. And there might be a lot of you that can do these in your head. But if you have an equation like 2 times x plus 4 minus 3 equals 3x minus 4 times 2 minus x. If you have something like this, can you solve this well without taking out your phone and going click and photo mapping the whole thing, right? Because that's what some of you did the whole year last year. So, I want you to think, can I solve this? I'm not sure it's a good equation. It may not have a pretty answer on that. But, can I solve this? Can I do it well? If the answer to that is no, I have no clue what to do there. I know I'm going to get mixed up. That scares me. Okay? If that's how you feel about a problem like this, then I want you to try to trust me, and I want you to write out these problems that we're doing today the long way. Okay? I occasionally have a student or two that is really good at solving equations. They can't do this in their head, but they can do 1 and 2 steps in their head pretty easily. I occasionally have that happen, but I usually find I have so many more students that say they can do it in their head, and they maybe can do 1 step, but then it just all starts falling apart after that. So, it may seem like a pain to write every bit of this out, but I would, because I've dealt with a lot of students that think they know how to do it all, and they keep getting the wrong answers over and over and over again, all because they don't write anything down. Okay? So, whenever you do a problem, let's just write the first one down here. So copy that first example problem down for me. You just got x plus 5 equals 10. And so, for this one, that x is our unknown number, right? A lot of people start just feeling angry when they start seeing letters put in math, all right? Because they shouldn't be there. But we're using letters, but we don't have to use letters. We could use a question mark, or we could use an empty box, right? It means we don't know what this is, and we want to figure out what this is. It's used a lot in real life. There's a lot of times that you have this situation and you don't know what this number is, this particular amount. For example, you want to drive from here to Winston, and you want to know how much gas do I need to get from here to Winston, right? So that's something you could figure out. That's your question mark. That's your variable right there. Let's say you've not got much money and you don't want to fill up the tank, right? So that's your question mark. So there's lots of things where we might be asking ourselves, what is this, right? So our variables are just our question mark. It's an unknown value. So this one, I bet you can already tell me what it is without doing any work. What would I have, Passion? It's 5, right? Because we know 5 plus 5 equals 10. So this is what I'm saying. You're going to be like, oh, I don't have to write this out. But we need to do it to get better at the longer equations. So one thing I always do is I draw me a line there on my equal sign. And that splits my problem into 2 parts. You finished saying? Yep. Good. You did not miss much of that. You can just take these notes on your paper right here. All right. So, x plus 5 equals 10. That line's going to split into 2 sides. So I've got my unknown number, and I've added 10 to it. How do I undo that? What undoes adding 10? Adding 5. Subtracting 5. So I'm going to subtract 5. If I subtract 5 on that left-hand side, I've got to subtract 5 over here on the right-hand side. Okay, this is the part a lot of people are doing in their head. And when you get really good at this, I don't care if you do it in your head. But until we get really good at it, I want us writing it down each time. Okay? Alright, so the reason we subtracted 5 is because we wanted to get rid of that plus 5. These are going to cancel out right here. So we just take our x, it's the only thing left on that left-hand side, and we're going to put it right here. And we over here do 10 minus 5, which is 5. So we're doing the opposite of that operation. Any questions on number 1? All right, copy down number 2 if you have not already. Two's a little more difficult to do in your head. Still not too difficult, but a little more difficult.
Can we do 75 plus 7?
I think it's a 15, although it does look a little like a 7.
I thought it was a 7 too.
That font looks a little like it's a 7, but it was a 1, so it'll be 15. Yes, plus 7 is what we're going to do. So, Julie, how did you know to add 7 instead of subtract 7? Because I see a minus right in front of that 7 and a plus behind it. You're correct. We need to add. So, but how do you know? Okay? We want to look at the sign in front of the number, right? So not the one behind it, although this does tell us we're separated by addition or subtraction, but we're looking at the sign in front of this number. So the opposite of the minus 7 is the plus 7. So we're going to draw our line. We're going to add 7 to both sides. Julian is correct. What will we get whenever we do that, Julian? 22. So this cancels. We just move our x down. And over here, 15 plus 7 is 22. Okay? Questions? Notice your x is on the right-hand side here. Sometimes I don't like that, but it's how it ends up on this problem. We could switch that and make it x equals 22 there at the end if we want. There. All right, 3 is one students have trouble with sometimes. What's happening right here between this 10, negative 10, and the x? What's happening there? They're right next to each other, which means they are multiplied together. So this is where students How many of you wanted to add 10 to both sides? You don't have to admit it. I'll make you raise your hand. But a lot of students usually want to add 10 because you're looking in front of this 10, which I just told you to do in the last problem, right? And you see a minus sign, which makes you think it needs to be positive. But whenever you got those two things right next to each other multiplied, how do we undo multiplication? Division. So here, we have to divide. And when you're dividing, we're not going to divide. We're not going to change the sign when we divide. We're dividing both sides by that negative 10. So the reason is that negative 10 divided by negative 10, what is that? Not 0. 1. Anything divided by itself is 1. Negative 10 divided by negative 10 is 1, which means we just have 1x, which is x, right? That's going to cancel each other out because it divides by 1. If we do a positive 10, we get a negative 1. We still have another step in the problem, right? So the negative 10s cancel. We'll bring down that x. 100 divided by negative 10 is negative 10. Okay, questions on 3?
So basically, the smaller number is mainly what we're subtracting.
Is whatever's on the same side as the x is what you're dealing with. So it's not always the smallest number, but whatever's on that same side as the x is what you got to get rid of because you want to get that x by itself. All right, now, questions like number 4, I put it on the quiz or a test, kids skip it. They don't even do it. Why do you think they might skip it? It looks like a fraction. And they have a panic attack, and they just skip the problem, right? But this is a super, super simple problem, right? It's not a difficult problem. We'll get to some that look like fractions that are difficult. This one is not one of them, right? Because this is just division. X divided by 4. How do we get rid of division? We multiply. So we're going to multiply both sides by 4. Okay? What we're doing there on that left-hand side, we've got 4 times x over 4, right? Which, this is not a fraction, but I could make it a fraction by putting it over 1. And if I have a 4 in the top and a 4 in the bottom, they cancel each other out, right? Which is what we wanted to happen all along, right? We want to get rid of that 4. So the 4's over here on this side, they cancel each other out, which is what we wanted. Over here, we're going to get 60, so x is 60. These are the 4 types of one-step problems you're going to see, right? You either need to add, subtract, multiply, or divide to solve. Today, there will only be one step. You're just doing one operation. There might be a couple in that worksheet that might have 2 of those negatives. I can't remember if it does a few in there, but we'll see those when we get to it. All right, so the last thing I want to point out here, and this I encourage you to do in your head, okay? Whenever you've got this answer, you can always plug it back in to see if it works. So you don't necessarily have to write all this down, but... Alright, so what we've done here is we've taken our answer. So in this case right here, we're taking that 5, we're plugging it in where the x was. So 5 plus 5. Does that equal 10? Correct. Over here, negative 7 plus 22. Does that equal 15? It does. Thumbs up. Over here, negative 10 times negative 10. Does it equal 100? Yes. And 60 divided by 4. Does it equal 15? It does. So you can check your work just by plugging those numbers back in. At this point, since it's one-step equations, you can really just do this in your head. You can write it out if you want. But think, does this number when I plug it back in? Okay? Alright, questions? Alright, so the first thing we're going to do today for our classwork is we're going to work on iExcel. So if you will go to iExcel, I gave you guys passwords for iExcel the other day. Yours was on your desk. Look behind your computer there. I said we weren't using computers after this, but we are. I forgot we were doing iExcel. Do you have your charger? Yeah, you can move over there. You guys need to charge those computers at night. Alright, so okay. So we are going to do iExcel. Unless I tell you otherwise, there'll be a few times we might use some iExcel that's not Algebra 1. But you are going to go to, mine's going to look a little different than yours, but Algebra 1. And we're going to be doing J3, which is one-step equation. So you'll just click on Algebra 1 and go down here to J3. Here. Now, it is going to give you some that are decimals. It might give you some that are fractions. Here. But it's that same idea. So, like, for this first one that it gives me, what should I do to solve that equation? Oh, you can't see that. Let me make it bigger. There we go. For this one, what should I do to solve that equation? What do you think, Passion? So, I got C minus 1.3 equals 5.35. So, there's my line. I got to get rid of whatever's over here with the C. It's a minus. To undo a minus, I got to put a plus 1.3. So, I'd add 1.3 to both sides. So, that's going to give me 6.65 for that. So, you'll type that in. Obviously, yours is going to be different. Yay! So, I have a smart score of 10 now. You guys have used iExcel before. Well, we used it here the other day. All right, so it's going to give you several different types of equations. So go ahead and start working on this. It shows me how many problems you're doing, what your score is. I just want you to keep working. If you get to 100, then I will give you your assignment that is going to be homework for tonight. I may, depending on how you guys do here, depends on how many I might give you on that assignment there. So, see if we need extra practice or not.